اوكي، السلام عليكم ورحمة الله وبركاته. اسعد الله اوقات الجميع بكل خير، واتمنى الجميع بصحة طيبة. Welcome all of you for today's lecture, and today inshallah we are going to study lecture number 4 in our course Instrumentation and Measurements 1. And as usual يا شباب, we first take the review or what we have done in the previous lecture. But before that, let me just remind you again for the quiz 1, and we say that quiz 1 will be in class and at week number 6. So next in the coming week will be week number 5, so it's the week after. So let's start with reviewing what we have done in the previous lecture. In the previous lecture, we started chapter number 5, talking about brochure, and we studied some basic concepts and principles about brochure. We know the formula of the brochures, and then in the next sections, we know the classification of brochure measurements, and we have known different types of brochure measurements. And the last section, we studied the hydrostatic brochure, which is talking about the fluid brochure, and in particular, we were talking about liquid brochure, and we conclude about hydrostatic brochure that the liquid brochure is dependent only on the type of liquid and the height of the liquid. Okay, so it's independent or regardless of the shape of the container, regardless of the weight of the liquid, and again regardless of the volume of the liquid, as long as the type of the liquid, which is expressed by the density, and the height of the liquid are same, so the pressure are same. So in today's lecture, we are going to study a new 2 sections, and these 2 sections are going to be very easy with one condition. I need from all of you, Shabab, to pay attention for the whole lecture. It's a very easy, but there are some points that you need to understand, fully understand, okay, in order to make it very easy. If you don't pay attention, if you miss these points, you will find it's very difficult. There is a no mid-range, there is no mid-points. So either it's going to be very easy, and these points are very easy to understood, or it's going to be a very difficult and you cannot understand the questions because you didn't understand these points. So the first section will be buoyancy, and the second will be Pascal law. Buoyancy, it means اللي هي قوة الطفو يعني طفو الأجسام في السوائل. So let's start with the buoyancy. Now the question is, what is buoyancy? What do we mean by buoyancy? Okay, let me start with another question or a thinking statement. So suppose that you have a ballon ball inside the water, and many of you have seen this example. Now, have you ever tried to push this ballon ball inside the water, to force it to be inside the water? Of course, if you try, you will find some resistance. It is somehow difficult to push it inside, and as you go deeper, you will find more resistance. Now the question is that who applies this resistance? Another question you might ask that why when you release your hand, okay, remove your hand from the ball goes up again. It comes back floating in the water. And now I'm saying floating, so the question is why it is floating in the water? Why it's floating in the water? You might answer that it's easy because it's lighter than the water. Well, let's see another example. See the left picture, you'll find this a huge and a super heavy ships, okay? These ships is weighed by tons. So why is these super heavy ships floating in the water, not sinking? And this a very small nail sink in water, in the same liquid. Of course, you cannot say the mass of the nail is heavier than these super heavy ships. And the other example, it makes it clear for you that this orange By the way, it's the same orange, okay? But it's a combined picture. So this orange, the top one is the orange with its peel, مع قشر. So you can see that the orange with peel, it's floating, while the orange without peel, بدون قشر, it's sinking. Of course, we know that the orange with peel, it's heavier than the orange without peel. So if you take the peel out, if you peel it, it means that you are taking some mass out of it. Well, all of these questions is going to be answered by studying the buoyancy, Now, what is the buoyancy? Let's define it. The buoyancy, it's the upward force. Pay attention, it's a force, not pressure. So the unit will be either Newton or pound force. It's not Pascal, not PSI. So it's an upward force, and this force is applied by the liquid. This force is generated, and the source of this force is the liquid. And it's acting on the object. And this object either floating or sinking in the liquid. Floating means يعني يطفو يعوم. Sinking معناها غرقان. Okay, مغمور في السائل. So from this definition we can understand 5 points. Okay, and these 5 points, it's very important to know. First, the buoyancy is a force. Second, this force is directing upward. Third, it's applied by liquids. So whenever you heard buoyancy, it means a force by liquid. Fourth, it's acting on objects. Fifth, this object may be floating or sinking in the liquid. So if we go back to the previous picture or example, you will see that we understand the buoyancy. Okay, we understand the buoyancy, and it's a force, sorry, and it's upward force exerted by liquid. Is there another force here? Yes, of course, there is another force. Now, what about the other force? The other force, since the buoyancy it's upward force, the other one is a downward force. Now, what's the downward force? The downward force, it is the force applied by the object due to its weight. So any object in a liquid, okay, there will be two acting force. The first force, it is the downward force, which is the weight of the object. And the second force, it's acting in the opposite direction, upward, which is applied by the liquid, and we call it the buoyant force. Now, let's remind ourselves by the weight formula, since we are talking about the downward force, it's the weight of object. So how can we find the weight? How can we calculate the weights? So the weight formula we know that the weight, it's equal mass multiply acceleration of gravity. And knowing that the density is equal mass over volume, we can say and express the mass in terms of density and acceleration of gravity. So mass, it's equal the density multiply acceleration of gravity, and at the end it's multiply volume. Okay, so these two represent the mass. Okay, so mass multiply acceleration of gravity. Now, since this is the weight formula, so it's easy now to find the weight of the object. So just represent each element by the object. So the weight of object is equal the density of object multiply the volume of objects multiply the acceleration of gravity. So now it becomes easy to find the weight of the object. Now the questions, we already understand one force, and we know how to calculate one force. What about the other one, which is the buoyancy? Well, let's try to find it. Now the question is how to find the buoyant force. Let's take an example. Suppose that you have a full cup of liquid, and let's make an example of water. And at the end, you can generalize it for any liquids. So suppose that you have a full cup of water, and you bring another cup which is totally empty, and you bring some other objects, okay? You bring some other objects. If you try to put this object, okay, for example, you bring this object, okay, if you try to put it inside this liquid, of course you would know that some of the liquid will comes out from the full cup of water. That's why we bring this one, because we need to use it in order to understand the buoyancy. So why some liquid comes out? Because this object has displaced some amount of the liquid. أزاح كمية من السائل بسبب حجمه. Since there is no space inside this cup for the liquid to move or displaced, it will come out into the other small cup. So let's see the picture of the object. This is the object. We put the object inside the full cup of liquid or full cup of water. We find that some liquid has been displaced by the object, and this liquid we put it inside a small cup. So the displaced liquid is inside this cup. This is the displaced or the amount of displaced liquid that has been done by the object. Okay. Now what can we understand from this example? There is a Greek scientist, عالم يوناني, it's called Archimedes, okay? He discovers the idea of buoyancy. He is the one who has discovered the idea of the buoyancy. And after that, he put something called Archimedes principle. And in this Archimedes principle, he said that the buoyant force, okay, the buoyant force, which we are looking for, is equal to the weight of the displaced liquid. See again the example, okay? Here's the picture. Archimedes said the buoyant force, we are looking about the buoyant force, so we are looking about B. Okay? He said that the buoyant force is equal to the weight of the displaced liquid. Where is the displaced liquid? This displaced liquid. All of these are displaced liquid. This is the displaced liquid. Why it's displaced? Because of the object. The object, when you put the object inside the full cup of liquid, it displaces some liquid. This is exactly the amount of displaced liquid. He said that if you take the weight of this displaced liquid, it is exactly the same as buoyancy. So now instead of this question mark, we can remove it and then write the buoyancy is equal to the weight of displaced liquid. Now we understand what is buoyancy or how to find buoyancy, okay, thanks to Archimedes. Now, this is an example, okay? So after we take the weight of the displaced liquid, we find that, for example, it's a 50 Newton. So now we can say that buoyancy is equal 50 Newton. Now, recalling the weight formula, okay, since we know that the buoyancy is equal the weight of displaced liquid, so we equate them, and then we apply the same formula of the weight of any object or any material. So the weight of displaced liquid now, it's equal rho, which is the density of displaced liquid, multiply G, okay, multiply volume of displaced liquid. Now here is the first point that you need to extract and understand from this definition and this principle. The question is how to find the volume of displaced liquid. I mean, suppose that the liquid here was not full. Okay, so if you put the object, of course it will displace some volume or some amount of liquid, but it might not comes out of the full cup. Okay, so this amount, how to find this amount? Well, the question can be answered by understanding one point, is that the displaced liquid volume is equal to the immersed part of the object, to the immersed part of the object. So الجزء المغمور من الجسم اوكي راح يزيح نفس الكمية من الليكويدز. فلذلك حجم السائل المزاح هو يساوي حجم الجزء المغمور من الجسم. So what if the object is totally immersed؟ يعني لو كان الجسم مغمور كامل. Okay. What's the volume of the displaced liquid? The maximum displaced liquid volume will be the same as the total volume of the liquid. And this is obvious. The object cannot displace greater than its volume. يعني أي جسم ما يقدر يزيح أكثر من حجمه. هو راح ياخذ نفس حجمه بالضبط. طيب if it was floating، إذا كان يعوم معناها it's not totally immersed، معناها جزء منه مغمور. So the volume of displaced liquid اللي هو حجم السائل المزاح will equal to the immersed part of the object. يعني راح يساوي حجم الجزء المغمور من الجسم. يعني أي جزء مغمور من الجسم راح يزيح نفس الكمية. Another example, see this one, see this example. Here we have some object floating inside water, okay, and you see that the black color, it shows the immersed part of the object. هذا هو الجزء المغمور من الجسم. The other part, which is this one, okay, it's out, it's in the air. So it doesn't displace any amount of liquid. Now, what is the volume of displaced liquid? Here we can say the volume of displaced liquid, it's exactly V dash, which is the immersed part of the object. Okay? So, now we understand the two forces. We understand the two forces. We understand the downward force, and we said this downward force is acting by the object due to its weight, so it's the weight of object. And we understand the upward force, which is called the buoyant force, and it's acting by the liquid, and we know how to calculate it by measuring or calculating the weight of the displaced liquid. وزن السائل المزاح، فقط السائل المزاح. Okay, now we understand that the object might have two situations. Is it floating or sinking? How to know that this object will float or will sink in water? So for example, this orange, okay, this orange is floating, while this one is sinking inside the liquid. Now, how to understand these 2 points? Well, the first situation is either the floating, the object is floating, or we call it floating object, and there is a one condition that the objects can float when the density of the liquid is greater than the density of the object. The density of the liquid is greater than the density of the object, and here be careful. Be careful. We are not talking about specific density. We are talking about something called the average density. Okay, the average density. So the whole materials, okay, that make this object, we are taking the average of all of these density. Now, what about the other one? It's the opposite way. For the sinking object, of course, the density or the average density of the object will be greater than the average density of the liquid or the density of the liquid. Now, let's start with the floating object. Let's study the idea of the floating objects. And now pay attention. Okay, now pay attention. We will extract some points that would help us in solving the questions. So, what is floating objects? Well, The floating object or the object will float only and only if it's an only condition if the upward force, okay, if the upward force, which we defined as buoyancy, and the downward force, which we call it the weight of objects, are balanced. Are balanced. And it's obvious, okay? The object, if the downward force is greater than the buoyancy, the object will go down because there is no balance, okay? The weight of object has dominant force than the buoyancy, so it will go down. However, it will float if the weight of object is equal to the buoyant force, okay? Is equal to the buoyant force. So this is the first point that you need to understand. The object will float if the weight of object is equal buoyancy. So whenever you see in the questions that the object is floating, you will say that weight of object is equal buoyancy. That's it. Okay? As long as you see in the question the object is floating, you will say that weight of object is equal buoyancy. Now let's write the formula. We know that the weight of object is equal the density of the object multiply acceleration of gravity multiply volume of the object, and this is equal the buoyancy, which is uh, equal the density of the displaced liquid multiply acceleration of gravity multiply volume of the displaced liquid. Let's take an example. Suppose that this ship is floating in water, okay, is floating in water. Now this ship has displaced this amount of liquid. This is the amount which is under the water. So it will displace the same amount of liquid. So this is exactly the volume of the displaced liquid. Now what we said that if you take the weight of this displaced liquid, it is exactly the buoyant force, okay? It is exactly the buoyancy. Now, since the object is floating, okay, the ship now it's not sinking, it's floating in the water, so we can say that the weight of the ship is equal to the weight of the displaced liquid, okay? The weight of this total ship is equal to the weight of this displaced liquid. They are equal. So if you if you bring some balance or balance scale and then try to take the weight or the mass of both the object and the displaced liquid, you will find they are the same. That's why it's floating. That's why it's floating. So here, for example, it's a 5,000 kilogram, which is the mass of the whole ship, okay? And the displaced liquid, only the displaced liquid, has the same mass, which is 5,000 kilogram. So that's all about floating objects, and we'll take example at the end of this section. Now we understand the floating objects. Before going to the sinking objects, one point to be understood is that first, once you see the object is floating, you will say directly that the weight of the object is equal to the buoyancy, and again the density of the displaced liquid, okay, which is the density of liquid, of course it will be the same liquid, is greater than the density of the object, okay, is greater than the density of the object. Now what about the volume of displaced liquid? The volume of displaced liquid will be the volume of this part only, which is the immersed part of the object. هذا هو الجزء المغمور من الشب، من السفينة، أوكي، أو من الباخرة. الجزء المغمور هذا عفوا هو نفسه volume of displaced liquid. Okay, now let's go to the next case, okay, which is the sinking objects. Now, in the sinking object, the object will sink, okay, we said that if the density or the average density of the object is greater than the density of the uh, liquid. Now, what can you get from that? You can get that when the object is totally immersed, the volume of the displaced liquid will be the same as the volume of the object. This is the same as the example that we have done before, that you can see here that this object is totally sink inside the liquid, and we can say that the volume of the displaced liquid, which is here, the volume of displaced liquid, okay, it's exactly equal to the volume of this object. Okay, so if you find the volume of the object, you can find the volume of displaced liquid and vice versa. So here example, volume of object is 1 cubic meter. Since it's totally immersed, it will displace the same volume, so the displaced liquid volume will be 1 cubic meter. So now in the previous case, we said in the floating object, we will get the idea of weight of object is going to be same as the buoyancy. Now we said that if the weight of object is greater than the buoyancy, it will sink, it will go down, so it will be the dominant. Now in this case, we can say that weight of object is greater than the buoyancy. Now apply the formula. Now see, what we can get, ya shabab, we can get that the volume of object, since it's sinking, the volume of object is exactly equal to the volume of displaced liquid. And of course, the acceleration of gravity here, it is the same amount and value of the acceleration of gravity in the other side. Okay? So, what makes the weight of object greater than the buoyancy? It is this one. The density or the average density of the object is greater than the average density or the density of the liquid. Okay. Now from the sinking object, if you try to think, when the object sinks down, okay, when the object sinks, its weight will change, okay, its weight will change. So if you try to take the weight of object outside the liquid, you will find it will measure some x value, okay? And if you put this object inside a liquid, you will find the weight is different. It will be less than its weight outside the liquid. Suppose, another example, if you try to hold you alone, if you try to hold some 10 kilogram object, okay, some 10 kilogram object, what you feel? You will feel the whole 10 kilogram. Suppose that someone, okay, try to help you to hold this object, and he put his hand by the object to hold the object. What you feel? Did you feel the same as the 10 kilogram now? No, you will feel less. Who take the rest? It is your friend, okay? It is your friend. Your friend, for example, suppose that it is a 10 kilogram, okay, and your friend hold 6 kilogram. What you feel is only 4 kilogram. What you feel is only 4 kilogram. So this 4 kilogram is called the apparent weight, okay, the apparent weight. So what is the apparent weight? It appears for you that it is 4 kilogram, okay, you feel it is only 4 kilogram, but it's in fact 10 kilogram. So what's the definition of apparent weight? This is an example for the apparent weight. Suppose this object outside the liquid, it measures 40 Newton, okay, 40 Newton. However, when you immerse it in inside the liquid, you will find it will displace some volume, okay. This is the volume that has been displaced, this area, and you will see that its weight has been decreased. So the apparent weight now, it has been decreased up to 30. Come on. Its weight, it's 40 Newton. and now it's 30 Newton. Why it's become less? Why it become less? Who take the 10? It is the buoyancy. Okay, it is the buoyancy because the buoyancy helped. Okay, the buoyancy helped the weighting scale. Okay, and lift 10 Newton. So now the weighing scale will feel only 30 Newton. Will feel only 30 Newton, which is now the apparent weight. So it appears for the scale that it is only 30 Newton. Why? Because the buoyancy has taken 10 Newton. So how to find the apparent weight? Before that, let's take the definition of the apparent weight. The apparent weight, it's the weight of object inside the liquid. Okay? The apparent weight, it is the weight of object وزن الجسم داخل السائل. So it appears lower. That's why we call it apparent. Okay? So it appears lower due to the buoyancy effect. بسبب تأثير قوة الطفو يظهر لك انها اقل وزن، ولكن فعليا وزنها ما تغير، ولكن الوزن الظاهري هو المتبقي من تأثير البوينسي. So it's easy now how to calculate the apparent weight. Okay, so now in the example we say that its weight, okay, its weight, the weight of object, it is 40 Newton. However, when we put it inside the liquid, it becomes the 30 Newton. So now 30 Newton, it is the apparent weight. What is left? We have 10 Newton. 10 Newton, it is exactly the buoyancy. Okay, it is exactly the buoyancy. So the buoyant force now, it is a 10 Newton. Okay? So the formula can be easily expressed as the apparent weight is equal to the weight of object minus buoyancy. So now in this case, or in this example, here we have the apparent weight is equal 40 Newton. Okay, sorry, it is a 30 Newton, and the weight of object is 40 Newton, and of course the buoyancy can be solved as 10 Newton. So 40 minus 10, we will get 30 Newton, which is the apparent weight. Now one question. Now we have ended the buoyancy. Okay, we have ended the buoyancy. But one question before going to the next example and exercise. Now, we said that we have two acting forces, okay, in for the object inside the liquid. Let me go back to the picture here. So here we have two acting forces for any object inside the liquid. One force is due to the weight of the object, right? While the other force is due to the buoyancy or the buoyant force. Now one question. We said in the floating objects, okay, in the floating objects, these two forces, okay, these two forces are balanced. Okay, and what do we mean by balanced? We mean that they are equal. They are equal. Suppose I bring the weighing scale, okay, I need to measure the weight now of the ship inside the liquid. How much do you think the weight of ship now inside the liquid? Now we said that the weight of object now is exactly same as the weight of object. So if you put your hand here, okay, suppose that you put your hand here, okay, what you feel? Okay, how much weight you feel by the ship? Suppose that the ship has a weight outside the liquid by 5,000 kilogram, okay, 5 tons. Suppose that it's inside the liquid now, it's floating in the object. How much weight you would feel? Of course, you will feel 0 kilogram. Okay, 0 kilogram. Who hold now the weight of the object? It is the buoyancy, okay? Since the buoyancy has applied and generated the same force of the downward force, okay? So now it push it upward, it make it float. So the apparent weight now, it appears that it has a 0 Newton or 0 kilogram of weight. So in the floating object, the apparent weight is equal 0. In the floating object, the apparent weight is equal 0. And again, let's go back to the same formula of the apparent weight, okay? And see here, suppose that the weight of the ship, okay? Suppose that the weight of the ship is, let's say, 10 kilonewton, okay? So we said that since it's floating, it means the buoyancy will have the same force that's make it pushing the ship upward and make it floating. If you subtract these two values, you will get the apparent weight is equal 0 Newton. So in the floating object, the apparent weight is 0. So whenever, okay, whenever, this is important to understand the questions again. Whenever you see a value of apparent weight, okay, if apparent weight is equal some value greater than 0, it means the object is sinking. Okay? Why? Because the apparent weight is greater than 0, and since it's sinking, we can extract that or understand that the volume of object is equal volume of displaced liquid. You see, when you understand the points, okay, you can solve the problems easily, but you need to collect and gather and make sense, okay, and make logic to understand these points. Okay, so that's all about the buoyancy. We have studied the definition of the buoyancy. We have studied the buoyancy effect, and we know how to calculate the buoyancy. And we said the buoyancy is equal to the weight of displaced liquid. And then we understand two cases of the object inside the liquid. We know that the object, it may float or sink in the liquid. And in the floating object, we understand that the object will float if and only if the weight of object is equal the buoyancy or the buoyant force. So the buoyant force will generate exactly the same force like that of the weight of the object. So the object will float. And we said in order to calculate or find the volume of the displaced liquid, we know it's the same as the immersed part of the object. So the immersed part of the object, whatever it is, whatever the value, it will be the same as the volume of displaced liquid. The second case is the sinking object. And in the sinking object, we said that in this case, the whole object will be inside the liquid. That's why it will displace the same volume of the object. So the volume of the displaced liquid will be the same as the volume of the object. And since then the object is sinking, okay, there will be something called apparent weight. So the weight of the object will be different inside the liquid than the weight of the object outside. So in order to calculate the weight, the apparent weight, we just take the difference between the weight of object and taken out the buoyancy effect. So minus the buoyancy, you will get what is left in the apparent weight. So now let's take some examples and exercise to understand the idea. The first one, this one is from the book. So the question is, what is the point force on a wooden cube? Okay, wooden cube يعني مجسم مصنوع من الخشب، مادة الخشب، with a 3 feet sides. Okay, with a 3 feet sides. What does it mean, 3 feet sides? Since we have a cube, it means that we have a 3 dimension، طول وعرض وارتفاع، مكعب. So 3 feet sides, it means that it has a 3 feet at each side. يعني الطول 3 feet, العرض 3 feet, والارتفاع 3 feet. Now he said this object is floating. See in the question, he said floating. Now you need to understand some point from the word floating. In water, so you know the liquid. So you know the density of the liquid. And he continued that he put a condition, or he put some statements that he said if the block is half submerged يعني immersed يعني مغمور يعني نصفه مغمور في الماء. There is no number in this question except 3 feet sides. How to solve it? How to solve it? Well, let's take it step by step. Let's take it step by step. Now, from what we understand that he asked for buoyancy, so let's write the buoyancy formula. Buoyancy, okay, is equal rho of liquid multiply the acceleration of gravity multiply the volume of only displaced liquid, not the whole liquid, the displaced liquid only. Okay. Now, do we have the rho of liquid? Yes, since it's water, we already said that you know all the properties of water. Do we know the acceleration of gravity? Yes. Do we know the volume of displaced liquid? No. Okay. So he said that the block is half submerged. So we can understand that the volume of displaced liquid is equal to the immersed part of the object. هو حجم الجزء المغمور من الجسم. Since it's half submerged يعني نصفه مغمور لذلك نصف حجمه يساوي حجم السائل المزاح. So it will be half of the volume of object. Okay, half of the volume of object. Now the question, do we know the volume of object or can we calculate the volume of object? Yes, of course, it's going to be very easy. We know the dimensions of the wooden cube and he said that the dimension of the object is equal 3 feet at each side. So the volume of the object is equal 3 feet length multiply 3 feet width multiply 3 feet height. Okay, so 3 multiply 3 multiply 3, you will get a 27, and feet multiply feet multiply feet, you are going to find or to have cubic feet. Okay, so the volume of the object now, the whole object, it is a 27 cubic feet. Now what about the volume of displaced liquid now? It will be equal to the half of the V of object, which is 27 cubic feet, and equal 13.5 cubic feet. So now we know the volume of displaced liquid, and now it's easily to find the buoyancy. So buoyancy again, it's equal rho of liquid, which is rho of water, multiply G, multiply the volume of displaced liquid. Now what about the density of water? We know that density of water, and I told you to remember it, the density of water is equal 1000 kilogram per cubic meter, This is in SI unit, and it's equal 62.4 pound mass per cubic feet. Now, which one is suitable to use? Okay, both are correct, both are the same. Okay, but which one is better to use in our question? Now, since all the units are in English and we have feet for the sides, cubic feet for the volume, it's better to use the 62.4 pound mass per cubic feet to fit in our questions. So let's write here 62.4, and it's better to write the unit in your answer. Okay, multiply 9.8, which is the acceleration of gravity, meter per square second, multiply the volume of displaced liquid, which is equal 13.5 cubic feet. And now what you can see that we have problem here. Okay, that we have problem here. Now, can I use acceleration of gravity here, pound mass? Can I use the acceleration of gravity meter per square second in English system? No. Okay, no. So in English system, what we said that they said if you have a density, okay, if you have a density as a pound mass, okay, per some volume units, you can replace the multiplication of acceleration of gravity. So I will remove this one by changing this mass, okay, with bound force, okay, with bound force. So here I will write bound force, and this is the specific weight. Okay, this is the specific weight. So now 62.4 pound force per cubic feet, and now we said that the specific weight is equal rho g, gamma, okay? Gamma of liquid now, it is equal the density multiply acceleration of gravity. So now the answer will be equal 8 to 4 buoyant, I think 16. Let me try to find it. 0.4, 842, sorry. Okay, 842.4. Now the answer is what? What's the unit of the answer? Now, as you can see that cubic feet will be cancelled by cubic feet in the denominator, so the unit will be pound force. So now the buoyancy is equal 842.4 pound force. Now what about the second part of the question? It says find the weight of the object. يبغى وزن الجسم الآن. What will be the weight of the object? There is a one word in the question. Okay, there is a one word in the question. If you understand it, okay, you will find the answer directly. You will find the answer directly. So try to find it. Try to find it. Let's go to the next example. And I will not solve it. I will let the question for you, but I will give some hints that would help you to find the answer or to solve the answer. He said here a block of wood with a density of 35.3 pound mass per cubic feet floats. Okay, so here he said floats in a liquid. Okay, in a liquid. He didn't mention the liquid. Okay, what's the liquid? It's not water now. Now he said floats in a liquid with a 3/4 of its volume. With a 3/4 of its volume, what? Submerged or submerged. What does it mean? It means that, suppose that you have here a tank. For example, this is a tank. Okay, sorry. and there is some liquid here, whatever the liquid, okay, and the object is floating in the liquid. He mentioned that 3/4 of the object or of the volume of the object is submerged inside the liquid. What does it mean? We understand this one, okay, is the volume of the displaced liquid. So the object will displace the amount exactly equal to the immersed part of its volume, okay? So we can say that volume of displaced liquid is similar to the previous one, is equal, instead of half in the first question, he said here 3/4. 3/4 it means 3/4. 3/4. 3/4 of the object. So the volume of the displaced liquid، حجم السائل المزاح الآن هو عبارة عن 3/4 حجم الجسم، لأنه 3/4 مغمور في الماء. So try to find it. And he said what is the specific gravity? Okay, the specific gravity of the liquid. So we know that the specific gravity formula, since it's a liquid, so we are going to use the formula of material. So specific gravity of liquid now, it's equal the density of liquid divided by density of water. Okay, so at the end you will find the density of liquid, okay, is equal some amount in pound per cubic feet. Okay, so you have to use the density of water in pound per cubic feet such that the specific gravity at the end will be a unitless quantity. Okay, this is another point to be understood. So first you need to find the density of liquid. You need to find the density of liquid using the formula of buoyancy and the weight of object, and since it's floats, you can say the relation between the weight of object and buoyancy, and from that you can solve for one of them, and then you'll say this is equal to that things, and at the end you will find the answer. Okay, if you find the answer, okay, this is a typical question. If you find the answer, it means you understand. It means you understand the points. Third example, a 15.5 kilogram mass. Okay, let me solve this one. Okay, a 15.5 kilogram mass of copper. So mass of object now, let me write mass of object is equal 15.5 kilogram. Therefore, we can find it's not mass to find, but let me at least follow the procedure. Sorry, not buoyancy. So the weight of object now is equal 15.5 kilogram multiply 9.8, which is mg. So the answer will be 151.9 Newton. Okay, Newton. Let's continue the question. He said it has an apparent mass of 8.7 kilogram. So the apparent mass, we have a value for the apparent. We said in the floating objects, the apparent weight or the apparent mass is equal 0. However, if the apparent mass or the apparent weight is greater than 0, it means the object is sinking. And if the object is sinking, we can say that the volume, blah, 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 you can continue the answer. So here, he said it's 8.7 kilogram. Therefore, the weight, the apparent weight is equal 8.7 multiply 9.8, which is 85.26 Newton. And he said it has an apparent weight in oil whose SG or specific gravity is 0.77. So the specific gravity of the oil is 0.77. And here we have kilogram, so SI unit and Newton. So we are going to use the properties and the density of water in SI, so 1000 kilogram per cubic meter. So we will use the SG of liquid. It's equal the rho of liquid divided by the rho of water. Therefore, we can say that rho of liquid is equal Sg of the liquid multiply rho of water, and at the end I can say it's equal 770 kilogram per cubic meter because it's 0.77 multiplied 1000. Okay, now what is the volume of the copper? He asked for the volume of the object and its specific weight, gamma of object, and we know gamma is equal the rho of object multiply G, because we are dealing with SI. If it's English, you just change, it is the same density, but you change the bound mass into bound force. Okay, now let's try to solve it. Let's try to solve it. Now he wants the volume of the object. Where can we find the volume of objects? The volume of object, we can find it in the weight of objects, right? So weight of object, this is how to solve. This is how to solve. You solve from your problem. My problem now is the volume of object. So the first question you need to ask yourself, where can I find the volume of object? Okay, so the volume of object is equal the rho of object multiply G multiply volume of object. Now, the question is, do we have the rho of object? No. Do we have G? Yes. Do we have the volume of object? No. Okay, now we have problem. Okay, now we have problem. But can we find the weight of object? Can we find the weight of object? Yes, it's already there. We have it. So here we have the weight of object. So now we have two unknown. Two unknown. We need to solve one of them. We need to find one of them. Now, in the question, he said that there is an apparent mass. Okay. So since there is apparent mass, it means the object is sinking. Okay. So we can say that since we have apparent mass greater than 0, therefore it is sinking. Therefore, we can say that the volume of object is equal the volume of displaced liquid, because since the object is totally immersed, it will displace the same volume or same of its volume. Now, we have now volume of displaced liquid. It can help us. From where we can find the volume of displaced liquid? I can find it in the buoyancy formula. So buoyancy now is equal the rho of liquid multiply G multiply volume of displaced liquid. You see, it's a long, It's a lot of thinking, but it's easy. It's something logic. It makes sense. If you just think, You can extract the information and the points and you solve it easily. But take your time, okay? Do not be hurry when solving. Like what I'm doing now. So buoyancy is equal density of liquid multiply acceleration of gravity multiply volume of displaced liquid. Do we have the density of liquid? Yes. It is 770 kilogram per cubic meter. Do we have the G? Yes. Do we have volume of displaced liquid? No. But do we have buoyancy? Now we don't have it, but we can find it. Okay? We can find it. How to find the buoyancy? The buoyancy can be found from the apparent mass formula. Okay? So now we can say buoyancy, it is the difference between the weight of object and the apparent mass. So we can say weight of object minus apparent weight. Okay, so weight of object is 151.9 Newton. Subtract the apparent weight 85.26 نيوتن. هذه معناها ايش؟ معناها وزن الكبر، وزن النحاس خارج الماء 151.9 نيوتن. لما وضعناها في الماء صار 85.26. من هو اللي شال الباقي؟ البوينسي. Okay, it's the buoyancy. So the buoyancy is equal the difference between them. Now the answer is 151.9 minus 85.26. You will get the buoyancy is equal 66.64 Newton. This is the buoyancy. Now substitute the buoyancy in the previous one. Okay, so you will get, and then try to solve for the volume of displaced liquid. Okay, so volume of displaced liquid now is equal the buoyancy divided by the density of liquid multiply G. Okay, so substitute the value, and then you will find that the buoyancy is equal 66.64 Newton divided by rho, which is 770 kilogram per cubic meter, multiply 9.8 meter per square second. We know kilogram meter per square second give me Newton. Okay, so we can cancel Newton with all of these, and this cubic meter is at the denominator of the denominator, so it will go up. Therefore the answer is going to be equal 0.00883 cubic meter. Okay, or I can say 8.83 times 10 to the power minus 3 cubic meter. Okay, so this is exactly equal the volume of object. The volume of object. So now we solved one of the problem, which is the volume of the objects. The question is continued and asked what will be the specific weight of the object. Now we know the specific weight formula. Okay, the specific weight formula is simply weight over volume. So we can write the specific weight of object is equal weight of object divided by volume of object. Now he asked for the specific weight, so directly substitute. You will say that weight of object here we have, it's 151.9 Newton divided by whatever we have solved now, which is the volume of object, 0.83 times 10 to the power minus 3 cubic meter. Okay, so at the end, as you can see here, you have a Newton per cubic meter, so the unit must be Newton per cubic meter, and the answer is simply equal 17,200.44, okay, Newton per cubic meter, or in other words, you can represent it as 17.2 kilonewton per cubic meter. So now you solve the question easily, but with full understand. You see, it's a very long, huh? Very long. But it's a very easy if you understand. It's a very easy if you understand. Now the next question, again, try to solve it. Okay, try to solve it. He gave you the weight of the object. Okay, a metal sphere weighs 29.4 Newton at air, so it's the weight of object, and 18.5 Newton in water, so this one is the apparent weight. What will be the metal's density? يعني the density of the object. The density of the object. Okay, so that's all about the buoyancy. Let's go to the Pascal law. Pascal law, it's a very easy. Pascal law, the scientist Pascal, he discovered the law, okay, that is greatly used now in the hydraulic system, and especially in the hydraulic press, as you have seen now. And he said that the pressure applied to an enclosed incompressible fluid, enclosed يعني محصور يعني if you press it from one side it cannot escape to some other side, so it's enclosed. And incompressible, it means that it cannot be compressed, so the density will be equal at all the time, so the density is not changing. Whenever you heard the word or you read the incompressible fluid, it means that the density is not changing. And here fluid, we are talking about liquid, okay, because most of the gases, they are compressible, so we are talking about liquids now. So let's continue. He said, Pascal said that the pressure applied to an enclosed incompressible fluid is transmitted to all points of that fluid، يعني تنتقل لكل نقطة من الفلويد. هذا البريشر it will be the same at all the points of the liquid or of the fluid, and also to the walls of the container. يعني this pressure applied at some point of the liquid, okay, it will be transmitted at all the points of the liquid inside this tube or pipe, and also the same pressure will be applied to the walls of the container. Now let's take an example. Suppose that you have a tube or pipe and you fill this pipe by some liquid. However, now it's not enclosed. So if you press it from this side, for example, okay, if you press it from this side, it will go from this side. So we cannot say it's enclosed. But I'm sure that this is incompressible liquid. So if you press it, the density will be the same. It will not change. Now, in order to make it enclosed, I bring the two pistons, okay, two pistons, ضاغطين. Now these two pistons, I put it in the opening end of that pipe or that tube. So now it becomes enclosed and incompressible fluid. Now to continue Pascal law, suppose that I make some force at this small piston, okay, so force according to the area of this piston, it will generate a pressure, because we know the pressure is force over area. So this amount of pressure or this applied pressure will be transmitted to all the points of the fluid, okay, so the pressure will be the same at all the points of the fluid and also to the walls of the container. Again, the same pressure will be applied here. Okay, this is the idea of Pascal. So the same pressure will be transmitted at all the parts of the fluid and also to the walls of the container. So what can we get from this formula? We can get that BS, and we mean by S, small piston, this one, this is smaller piston, is exactly equal to the BL, which is the pressure in the large piston. So the pressure here, which is BS, will be equal pressure here, which is BL. S, small piston, large, it means large piston. Now we know the formula of the pressure, it is force over area. So at BS, it means that the force at small piston divided by the area of that small piston, and BL, it means that force on the large piston and area of the large piston. What can you get from this formula? It means that if you apply small force, small amount of force, okay, on this very small area, and suppose that this area is, for example, 10 times greater than the small area, okay, 10 مرات أكبر, so it will generate a 10 times greater force than the initial force. Why is that? Suppose that you have here, you apply the 1 Newton, okay, over, for example, 1 meter square, small force, a small force over a small area. Suppose that you have a 10 times area of the other piston, of the large piston, okay, greater than the small area. So 10 times, it means here 10 meters square, okay. What will be the force generated in the large piston? Because of 1 Newton, you generate 1 Newton, and in order to have the equality between the pressures, so here there must be 10 Newton. So you apply 10 times force greater than the initial force. Okay, so the answer here, the pressure here is 1 Pascal, and here again it is 1 Pascal. So at the 1 Pascal, sorry. So at the end you can say that the pressure are same. Now that's all about Pascal law. That's all about Pascal law. So let's take some examples. Here in the book, he solved this question, and at the end, there is some mistake, okay, in the solution. In general, okay, try to solve it, but in general, we say that BS, the pressure at small piston, is equal the pressure at large piston. So we say that the force on small piston over area on the small piston, again, it is the same as force on large piston over area on large piston. Okay, so let me find the fourth. You can make the cross multiplication to find the unknown. For example, if you know this one and know this one and know this one, but this one is unknown, how to find it? So let's try first to solve for the area of large piston. So AL is equal FL over Fs multiply AL. How do I get this? Because if you cross multiply, you will find that Fs, it will be multiplied by AL, and this is equal the cross multiplication, the other part of the multiplication, you will have FL multiply AS. Now what you have known, you know this one, and you know this value, and you know this value, and you don't know this one. So this Fs, it will be here as denominator. So at the end you will get FL over Fs multiply, sorry, here Fs AS, sorry. So here I should write AS. Okay, so and you can apply the same thing for the other. Now this question is easy. He said that if the area of the small piston AS is equal 0.3 meter square, so AS is given, and the area of the large piston AL is 5 square meter, so it's given AL. What's the force FL? He asked for FL, okay, of the large piston if the force Fs on the small piston is 85 Newton. So 3 is given and 1 is left. FL, try to find it, okay? Try to find it. So this one, it will be transferred to the other side, okay? This one, it will be transferred to the other side. Now, the second question. He said two pistons connected by a pipe are filled with oil, okay? The larger piston has 3.2 feet what? Diameter. Okay, the large piston has 3.2 feet diameter. Okay. So it's not the area now. He gave you the diameter, and since it's a diameter, so it's a circle. Now, and has a force of 763 pounds. So let me write. The larger piston, he said, has a diameter of 3.2 feet of length. Okay, so DL, I will write DL here. It means the diameter of larger piston is equal 3.2 feet. And he said has a force of 763 pounds. So if at large piston is 763 pound force, of course, applied to it. Now the question is, what is the diameter of small piston if it can support a force of 27 pounds? So Fs now is equal 27 pounds. The question he asked for the diameter of the small piston, so ds is equal. Now, easily you can apply this formula and try to solve it. Okay. So here we have the area of circle is equal by r square, and r is equal the diameter over 2, which is the half of the diameter, نصف القطر, diameter هو القطر. And of course d is equal to r. Okay, and r can be found from the area as, since we have the area is by r square, so you can divide the area by, and to take out the square, you take the square root. Okay, so using this formula, and of course the formula of Pascal law, which is Fs over As equal Fl over Al, and we mean by Fs the force on small piston, it's given. Okay, so we have force on small piston, we have force on large piston, and we have the diameter of the large piston, so we can find the area of the large piston. After that, you will find the area on a small piston, and then find the diameter of the small piston after that. Okay, so after finding the area of small piston, you will find the radius, and after the radius you will find diameter. There are some shortcut ways, okay, that I will not some of you, of course, they know that since the area is by r square, okay, and we know that r is equal d over 2, so you can say d over 2 all square. If you distribute the square in the numerator and denominator, you can see that it's a pi d square over 4, and you can use this formula all the time. Pi over 4, take this 4 outside, multiply d square. So again, this is the area of circle. So according to what is given to you, you can use any formula, but the main formula is pi r square. You can use it, and then you substitute the values. This will be long for you, of course, maybe 2 steps extra. If you know the pi over 4d square, okay, you will shortcut by 2 steps, but do not memorize more than one formula. This will make confuse for you, and you will mix. What I mean by mix, maybe you'll see, or you write pi over 4r square because you mix the things together. So by practicing, you will find this is easy to be used. Any formula, you will find it's easy. Okay, so try to solve it. This is it's given the final answer. Now another one, it's given a piston 8.7 inch diameter. Okay, has, so I don't know, is it small piston or large piston? Let me see. He said a piston 8.7 inch diameter has a pressure of 3.7 kilopascal on its surface. Okay, what force in SI units is applied to the piston? So he asked about force. So we will not use the Pascal law, we will use the pressure formula. So the pressure formula, we know it's B is equal force over area. Okay, so the force now is not given. Okay, he asked for force. The pressure is given, but it's given in SI unit, kilopascal, kilonewton per square meter, and the area is half given. He gave you the diameter in inch. I put this question because it's typical question for the pressure. It's easy to apply the formula, but there is a unit conversion, and then find the area, and then convert it, and then multiply the pressure by the area to find the force. So what you need here, pressure is given as 3.7 kilopascal, which is kilonewton per square meter. Okay, so you might convert it into Pascal to make it easier, which is a Newton per square meter. And you know that let me give you a relation between inch and meter. So 0.305 meter is equal to 12 inch. From where I find this one? I find this one from 1 feet. So I don't need to memorize this one. If I memorize these two, 1 feet equal 12 inch, and the same 1 feet is equal 0.305 meter. Since these two, okay, since these two are same 1 feet, so of course these two are the same, equivalent. Okay, so I can say that 12 inch equal 0.305 meter. However, this is between meter and inch. In order to find the relation between square meter and square inch, you can square both sides and find the answer. So it's up to you. You can try to solve it. Try to solve it. I will not give more hint rather than this hints. Okay, so it's up to you. Again, we know that the area is equal by r square. So here you have a diameter, so you need to convert it to radius and then square it, or you can use this formula pi over 4 using the diameter directly. Okay, d square. So it's up to you. Do not mix the formula, do not mix the things. If you don't understand how to bring this one, okay, use this one. Be in the safe side. Be in the safe side. Okay, you have two more steps, but at least you are making sure of your answers. Okay, you make sure of your answers. So that's all uh, in our lecture. In this lecture, we studied the buoyancy and the Pascal law. In the buoyancy, we understand different concepts, and we know how the objects floating and sinking, and what's the conditions of floating and sinking. We know that for the floating objects, it means that both forces, the two forces, are balanced, so both are equal. What are the forces? We know that they are the weight of the object, which is acting downward, and the upward force is the buoyancy, which is applied by the liquid. And the buoyancy can be calculated by calculating the weight of the displaced liquid, not the whole liquid, only the displaced liquid. And the liquid, this displaced liquid has been displaced by the object. Okay, so whatever the volume of the object is immersed or inside the liquid, it will displace the same of its immersed part. So if the total object is totally sink, so the total object is inside the liquid, so we can know that the volume of the displaced liquid is equal to the whole volume of the object. And this is for the case of the sinking. In the sinking object, we say that the weight of the object is greater than the buoyancy. However, in this case, the weight of the object inside the liquid will not be the same of its weight outside the liquid. So this weight, we call it the apparent weight, where we measure or calculate the object, the weight of the object inside the liquid. And then finally, we know the Pascal law, and we said that the Pascal law, it's applied for some enclosed incompressible liquids. And we said that incompressible, it means the density doesn't change. Enclosed, it means it's closed at both sides for any pipe or tube. So if you apply some force on some area of piston or at one end, it will generate a pressure, and this pressure will be the same at all the parts inside the tube or the pipe. And again, it will generate the same pressure on the walls and the pistons on the other side. So according to the area of the piston, according to the initial force given, you can calculate the different elements of the pressure. And we have taken some examples, try to solve some examples. Again, I'm saying again and again that try to solve the problems in the book. So this is the page of the problems. So starting from this one, okay, here page 82, you have 2 pages of problems. Try to solve them. Okay, try to solve them. You have 20 problems here. Okay, you have 20 problems. I think we already covered some of them in the lectures. We try to solve them, and I let you solve some of them, but try to solve all of them. Try to solve all of them. If you practice and solve all of these questions, it's going to be very easy, and you cover all the subjects in this chapter, and no one gonna challenge you for any questions in this chapter. So hope inshallah for you, best of luck, and see you in the next lecture.